So the first talk this morning is entitled Contributory, Collaborative or Co-Created Citizen Science on the River Chess. And what we're going to start to do is just tell you a little bit about the wider River Chess initiative, first of all, that the citizen science activities are embedded within. So I'd like to introduce Helena Soterio-Haynes, who's going to just give you a couple of slides of introduction to the Smarter Water Catchments initiative.
I'm Helena Soterio-Haynes. I'm the head of River Catchment, part of that kind of Smarter Water Catchments initiative, which I'm sure many of you in the room have heard of before. If you haven't, it's a kind of trial project that we've been doing for the last four years now, since April 2020. And it's covering 3 trial areas. And the slide before this just had the map of those trial areas, which is fine. I'm sure we can circulate those after. So here in the Chess, we've got another trial project in Evenlow catchment and another one in the Crane catchment in West London. And what we really set about doing in 2020, or before that actually, at PR19, which is, for those of you that know, these kind of 5-year price review cycles that the water industry go through. We set about a kind of a bit of a test bed, really, to try and work out the best ways of co-creating, co-delivering and co-funding a whole range of different projects that would help kind of improve the river catchments and kind of trying to understand how sort of different stakeholders and communities can interact with that project. So kind of historically, the water industry has been quite kind of single issue focused. Been quite good at really targeting one thing, but this project is all about trying to bring together all of the problems that we might experience in a river basin and try and kind of tackle them, essentially. So on the slide, and for those at the back, there's just a kind of some principles of what we sort of set out to try and achieve. So really, this model was a bit of a test bed. We didn't know how successful or not it was going to be. So we've really kind of been learning a lot about kind of working together. And I'm sure we're going to talk a lot about the citizen science element of that today. But for those of you that are interested, we can kind of share any other material about the project.
Thank you, Helena. Great. So, as Helena said, this is very much a partnership project. So it was really important to get on board all the different partners within the catchment that were interested in river health and also in the wider health of the wider River Chess catchment as well. So from the very beginning, we have obviously the 2 water companies in the area, Thames Water and Affinity Water. We have local river pressure group, the River Chess Association, the Chiltern Chalk Streams Project, Chilterns National Landscape, Chilterns Society, so local charity as well, that's doing lots of great work around the Chilterns. We've got Buckinghamshire Council, local authority, Environment Agency, Herts and Middlesex Wildlife Trust, and Queen Mary University of London, our academic partner as well. So all of the people, the organisations around the table from the very beginning, sort of planning the wider Smarter Water Catchments work and getting involved in citizen science. The actual Smarter Water Catchments overall project has 6 different themes, and the citizen science interacts with all of these different themes. It was set up originally with the view of looking at water quality, but we've really widened the remit of that citizen science. So we've got managing the flows, controlling invasive non-native species, improving wildlife corridors, involving people, and working together. Those are the 6 wider themes for the wider Smarter Water Catchments initiative, and the citizen science sits within those themes. So there are 3 different models of citizen science. Contributory citizen science, which is defined as being set up by professional scientists, and the volunteers contribute data to the project. The second category is collaborative, where projects are strongly shaped by volunteer participants. And the third category, called co-created, is where professional scientists and volunteers work together to design the project. And there's lots of debate in academia about the different roles of these different types of citizen science. And I'm going to just come back to that at the end of the talk, just to reflect on our experience in the River Chess between these different modes of citizen science. When we started off with our citizen science programme, we asked, first of all, what are the objectives that we want out of this, this programme of work? So I thought it would be for other rivers groups interesting to think about and reflect on what are your objectives for your groups as well that you're putting together. We asked ourselves, are we gathering data? If so, what is the purpose of the data that we're trying to get? Because we started off saying, well, there's so little known about different aspects of the River Chess. It hasn't been very widely studied. But we really wanted to make sure we understood, first of all, what data had already been collected in the catchment, so that we weren't just duplicating effort that others had already had gone to. So we looked at all of the existing open data sources that we could find, and we requested additional data from both the regulatory authority, so from the Environment Agency, and also from the water companies, to put together the full picture of data that was out there on the River Chess already. And the other thing, reflecting on the kind of process that we went through, was making sure that you've got all your key delivery partners together as well from the very beginning is really important, so that you can understand what the barriers might be to action after you've collected all of your data. So I'll give you an example of that later on, but that would be one of my sort of key take-homes. We'll come back to that at the end. So there's lots now. When we started in 2019. There weren't so many open data portals out there. Now there's so much data out there online that you can access and have a look at. So just to take you through a few of the different kinds of examples of data that you can get about your river, there's the UK Centre for Ecology and Hydrology's Water Resources portal, which is excellent if you want to look at flow data, rainfall data, for example. That's all there from the sort of official gauging stations and rain gauge network sites. The Environment Agency have their water quality archive, and that's all of the, where they take any water samples, that goes up on this archive, which you can explore via a map or other means. Again, a brilliant source of all of the water quality data that will exist from the Environment Agency for your particular catchment. So that's a great resource to look at. I'm going to go back on that. The Environment Agency also have all of their sensors online now as well. So there's a portal that you can actually go in and have a look at the continuous water quality data if it exists for your catchment. This is invaluable, the River Trust catchment-based approach data hub. They've brought together so many different types of data about your catchment, opportunities, issues, characteristics of the catchment, causes of pollution problems as well. So that's a really invaluable resource for you to take a look at. And then more recently, we've seen the launch of the Watershed Pollution Map, where all different sources of data have been brought together as well for the UK. So you could also have a look at this resource. The Environment Agency recently have released this alert tool as well. This allows you to see in your catchment where overland flow might occur. So it's a theoretical mapping tool that you can have a look at to see if you're concerned about overland flow, for example. So again, all of these things are things that are now available online and free. So if you're a citizen science group starting off, these are excellent resources to have a look at. Affinity Water in our area has created this environment data water portal where they've brought in all of their data as well so that you can have a look at that online. So, and other water companies are doing the same type of data online now and to be open and transparent about their data. So when we started to think about the River Chess, we understood that looking at river health entails not just looking at the water quality, but also understanding the flows in the river system and also the natural habitat as well, and how you can improve the natural habitat. So this plot, this graph of the clean water, the natural flow and the natural habitat now is something you may well have seen before in relation to chalk streams, but really important to consider when you're thinking about any river system, how these three things link together if you want to do something to improve the river health. So we started off with saying, well, what are the knowledge gaps? What don't we know about this river? And we divided the river into different reaches according to the land use and according to the critical river inputs and the activities taking place. And we produced maps with the monitoring activities that had been carried out in each reach on the map so that we fully understood what data sources we had about each reach, and we looked at the frequency of monitoring, what was missing. We brought together not just data from the Environment Agency but also from local rivers groups as well. So for example, river fly had been happening in the River Chess for many years before we started this project. So we made sure that we brought that data into the database that we had from the start. And we were looking at everything from invertebrates, fish, plants and habitat, also through the Environment Agency data set. So we ended up with a series of maps for each reach where we were looking at where we'd had water quality measurements taken, quantity measurements and ecology measurements taken. Ideally, you'd want flows, water quality and ecology to be monitored together, but this isn't often not the case. So that was part of what we were trying to do, was harmonise that monitoring as well, so we had access to all this data down the reaches. And we also wanted to look at the WFD, the Water Framework Directive, reasons for not achieving good status as a starting point, to understand what were the issues identified by the Environment Agency on the river. I don't expect you to read this, but what we did was essentially put together a table of all of the issues that we've identified on the river. So, for example, that wastewater was a big concern for us. Sediment transport to the river was a concern, and nutrients of unknown origin in the river as well. And so for each of these, we saw what's the issue, what was the evidence base on which we were taking our concerns forward, what was the location in the river that we were particularly concerned about, and then we had a methodology and a recommendation then for each of these issues so that we could create our citizen science around that. Come on in, do sit down. Yep. Yeah, up the front if you'd like to, that's absolutely fine. So the baseline study that we did is available along with our other reports on the website as well. So if you want to have a look at how we've set this out, you can download that information. So we based our citizen science activities around this table and these questions that we were asking. So just to give you an example of one, we were really concerned about Chesham sewage treatment works and the storm tanks overflowing and when that was happening and how frequently it was happening. And at that point in time, we weren't too sure of the reasons why and the frequency. And we wanted to know what was the effect on dissolved oxygen levels in the River Chess. Where the Environment Agency data was telling us that dissolved oxygen levels in the Chess were good, but we knew that back in time when storm tanks had been overflowing sort of a number of years before, that we'd had fish kills on the river. So we wanted to have our own data set for understanding what was happening with regards to dissolved oxygen. And we wanted to know whether any storm tank overflows that were occurring were affecting invertebrate health as well. So those were sort of three questions that we grouped together. And we thought about what citizen science would we need to answer those questions. And from that we decided, right, we needed water quality sondes. We needed a way of interpreting that water quality sonde data that we got. And we needed to have another technique, which Smart Rivers by Wildfish gives us, which is a technique where we can use invertebrate data in order to understand whether there's a kind of issue with invertebrates from organic matter in the river system. So we've put those different citizen science activities together. I'd call the water quality sensors was co-created. So I was at that time at University of London. I had some sensors. I was approached by Paul Jennings of the River Chess Association and by Alan Beachy of the Chiltern Chalk Streams project and asked whether I would help out putting water quality sensors in the river. We secured some funding from Thames Water and we took some sensors that had been purchased originally for research purposes and we put them in the river where the Rivers Group wanted them to be. So after we'd done our sort of baseline assessment. So that was, I would call that very much co-created citizen science. The sonde data interpretation, we were so lucky. We had someone come to us during COVID and say, I'd really like to help you out with your data interpretation and create an online database and a portal whereby you can see your data online. So we worked with a citizen scientist to do that. I'm going to call them expert because they had expert skills from another area of work that they brought to the project. And that's something we've found increasingly with everything that we've done, that there are so many people with expert skills in other areas that can be brought to bear on citizen science and really help us with that. I'm not going to go through these slides in detail, but they'll all be available to you after the event. But we learned lots of things very fast when we started to employ these sensors in the river for long periods of time. They're there continuously. They're sitting there exposed to all the conditions that are happening. They absolutely have to have wipers on them to clean them before they take measurements. They get crayfish stuck in them, they get algae growing on them. There's a really strong cleaning and maintenance regime that we have, and that costs money and it takes people to do that. It's not an insignificant task to keep these types of units going in the field for a long period of time. And of course, we've got to calibrate them as well on a really regular basis. We calibrate them monthly. It costs us money in calibration solutions, and we need to keep that rigor to the data to be able to use the data. Lots of us have experience here today in the sensors, and we can tell you all about it if you're interested in that aspect. I'm not going to go into detail now. We've got posters around, and we can direct you to all those people that have been involved in looking after these sensors. And what have we really learned sort of 3 or 4 years on? We know now that the storm tank overflows in the Chess occur due to a combination of things: high intensity rainfall, but also groundwater ingress into the sewer network. So there are 2 different reasons there. They can cause both transient and longer term changes in dissolved oxygen, depending on the cause. So when groundwater levels are high and groundwater ingress is occurring in the sewer network, we were seeing longer time periods whereby there were storm tank overflows. Thames Water has put lots of capital investment in increasing the treatment capacity at Chesham Sewage Treatment Works, and they've invested in lining the sewer network and sealing manhole covers as well in the area, but it hasn't eliminated the storm tank overflows from occurring under both high groundwater level conditions and intense rain. So I don't want to give you the impression that by putting these sensors in, we've been able to solve the problem. But what we have done is, as a result of having this data online, we have open online continuous data from our sensors, and it can really help the dialogue between the water companies and the local rivers groups. We're really empowering, I think, community groups through knowledge. Everybody, I think, is more upskilled in understanding what's happening in the river, being able to have meaningful conversations about levels of oxygen in the river, what that means for the river, and what's happening in real time as well when events do occur. So again, if you're interested in the sensors in any other way, then just do talk to us about that. And then just in terms of another set of questions, fine sediment, we asked, where's fine sediment coming from? What locations is fine sediment entering the river? What impact is the fine sediment having on ecological health? And we put together consultancy work, Mud Spotter, which is contributory citizen science. It's a toolkit that we used, with Smart Rivers and Modular River Survey as well to help answer those questions. There's lots around here about Mud Spotter, and other people will tell you a little bit about Mud Spotter today. But what did we learn from that? It can take years to collate the evidence before mitigation actions take place when it comes to fine sediment issues in rivers. Many rivers are going to need long-term investment to help drive catchment scale change in this area. Where road runoff and connection with road networks an issue, we do need to be developing local collaborative partnerships with local authorities and with Highways England as well. And capital investment's not enough. You need to be thinking when we're trying to think about solutions. So we've found several areas where fine sediment's getting into the Chess. We know what we want to do, but making those links with the local authorities and finding the budget to do it is difficult. And then you also have to have someone to maintain the structures that you have put in place. So the maintenance is really important. So this is why I'm saying have those local authorities, have them in your network from the very beginning so that everybody is sort of talking to one another about what the possibilities are from very early on. And without change at a national level, in some areas it's going to be really difficult, I think, to address road runoff. There's currently no obligation or requirement for local authorities to do so. So that's a difficult one. I wanted to give you an idea of costs, because this hasn't been done with a small budget. We've been really lucky here to have a large budget. Helena was saying earlier on £3 million over 5 years to the Chess. So the citizen science hasn't been the full £3 million, but it has been a good proportion of the budget. And for the kind of scale of effort that we've put in, we've pretty much got 2 full-time staff working on the citizen science aspect. So we've got Hannah as a citizen science coordinator, But we also have Tom from Queen Mary, some of his time, we have some of my time, we have lots of other people contributing. You'll see lots of people from the Chilterns Chalk Streams project here today all helping out. So that's the big cost. We decided to invest in sensors. That is a really big cost to have these water quality sensors running as well. And then we've got other equipment, training, events, consultancy. So I've included that and wrapped that into it as well. We've gone to consultants for certain pieces of work, and then feedback via events. So again, other people will be going through this, and Hannah will take you through this aspect a little bit more. So we've blended different types of citizen science. I don't think you need to think about whether you're contributory, collaborative or co-created. You can do lots of different types of citizen science within your catchments. And you can link more than one citizen science toolkit to answer your questions as well. But do keep turning back to the regular questions that you've asked, your critical research questions, to make sure you're on track all of the time. And you're not just collecting data for collecting data's sake, because it's really easy to do that as we all get so enthused about collecting the data out in the field. Involve the partner organisations in your planning from the start. And then my final thing is have a look at the posters around the room today. We've put up most of the different methods that we've been using, and we're all on hand to tell you a little bit more about what we've been doing over the last 4 years. So I hope you enjoy the day. Thank you.